Hi everybody, I wanted to do a little video of how to do simple regression in SPSS, and I'm going to use the data file that we used for Lab 7 just as an example. Basically, if you can follow along with this video, there's no doubt you'll be able to do Lab 7 if you haven't already done so, and uh, no doubt you'll be able to do the homework that'll be assigned this week with the exercise 21B data set. I'm going to use the example that we talked about in class for lab where we want to see if there's a relationship between how many math units a person takes in high school and their grade 12 math achievement. So same example as in class. So to do a simple regression, we're going to go to Analyze, down to Regression, and then you're going to pick the option that says linear regression. Okay, so like in the lab from last week, we said that how many units of math you take is going to have an impact on your achievement. So therefore, math units is your independent variable. So you're going to click that and click it over to independent. And grade 12 math achievement is going to go up in the dependent box. And that in itself will just run the simple regression, just because some of the questions on the exercise 21B homework will ask for it. We're going to go to the statistics box and then just check off a couple of extra boxes. For example, R squared change, descriptives, okay? And then the last question of the homework asks about residuals. So basically how far the actual data point is from the best fit line. So go down to the residuals option and click case-wise diagnostics, and we're going to want to look at all cases. Okay. As you'll see with the exercise 21B data set, though, you'll have much less data that you're working with. Okay. And the reason why I clicked the descriptives box in particular is because it'll give you not only the correlation between those two variables, it'll also give you the mean and standard deviation for both of those variables, which you might need that information for exercise 21B. Okay. Okay. So you see at the top, okay, there's your descriptive statistics. So there's the mean and the standard deviation for each variable, okay? And in this case, the math achievement variable would be your dependent or y variable, okay? If we wanted to know the variance based off this this table, okay, basically we learned that to get the standard deviation is the square root of the variance. So to get the variance, you would do the opposite. So we have the standard deviation here of 14.00 and change, right? So to get the variance, you would square the standard deviation. That'll give you the variance of the dependent variable. Okay. Go down to the next box. You have your correlation between math units and math achievement, and it's 0.521. Okay. If we want to know if that correlation is statistically significant, we could look at the significance box right underneath it. But keep in mind that it says significance for a one-tailed test, okay? So that would be if you're doing specifically either just the greater than test or specifically the less than test, okay? So if you just want to know if there's a relationship between those two variables, that is a two-tailed test, okay? That is equivalent to doing a not equals hypothesis test. So if your research question happens to be two-tailed or not equals, then you have to double the p-value here. So that way you get it for a two-tailed test. Now obviously in this case, because it's 0.000, you multiply that by 2, it's still going to be 0.000. It's going to be significant any way you look at it. Okay. Go down to the model summary box. Okay, there's the R again, or a correlation. Okay, right next to it is the R squared value, which we call, which is the proportion of the variability in the dependent variable that's explained by the independent variable. So in other words, 27.2% of the variability in math achievement can be explained by how many math units you take. Okay. We have our ANOVA table. Just this ANOVA table is going to tell us if our overall simple regression model is significant. So in other words, is that one predictor significant? And use the same rule of thumb. Okay, look at the p-value. Okay, if it's less than 0.05, that means yes, there is a significant relationship between math units and math achievement. Okay, and keep in mind when you're doing an ANOVA test, you don't have to do the one-tailed, two-tailed rule there. Okay, ANOVA is ANOVA. Okay, just like when you did it for before the midterm. Okay, whatever the p-value is out of ANOVA, it is what it is. Okay. Um, one of the things that's different. One of the things that I just want to highlight in this ANOVA table, okay, is let's clear that box out. Okay, the mean square residual here is what you've called in the past the pooled variance. In the case of regression here, this is going to be considered the variance. The mean square residual is the variance of the residuals. Okay, so when you get to that question on your homework, that is going to be the mean square residual. Okay, variance of the residuals is the mean square residual. Okay. Okay. Now we have our coefficients box. Okay, the constant refers to the y-intercept, and the number of Carnegie units is our independent variable. Okay, the unstandardized coefficient beta, these are the actual coefficients of your regression line. So basically, we have this equation would be y equals 24.923 plus 0.076x, where x stands for number of math units. Okay, right next to that column, you have your standard errors. Okay, typically, we only care about what our independent variable is. We don't really care about the standard error for the constant term. Okay, and then right next to that column is the standardized coefficient beta. So basically, instead of talking about things in raw units, okay, we're talking about things in terms of standard deviations. So if we take a look earlier at the 0.076, the unstandardized coefficient, okay, we interpreted that before as math units increases by 1, math achievement goes up by 0.076 points. Standardized coefficients talk about everything in terms of in terms of standard deviations. Okay, so it actually, in this context, okay, the 0.521 actually means a 1 standard deviation increase in Carnegie units results in a 0.521 standard deviation increase in math achievement. So everything is in terms of standard deviations here. Okay, you have your t statistic right next to it. Okay, and the p-value. This p-value here is for a two-tailed test. Okay, if you the actual degrees of freedom associated with that t statistic comes from the residual of your ANOVA table. So in this case, the t statistic has 221 degrees of freedom right here. Okay. Okay. If you're specifically looking in one direction, though, so in other words, you think that there's a positive relationship between how many math courses you take and math achievement, okay, that is a one-tailed test, so therefore you would divide the p-value here by 2. As you can see, no big deal, right? It's still going to be 0.000. And then the last box here is our residuals. Okay, so this basically tells us how far each actual data point is from the line. So for the homework itself, okay, the residual column tells us how far each point is away from the best fit line. So the bigger numerically the residual is, so the bigger the absolute value of these residuals, that basically means the farther away that point is from the best fit line. Okay. The smaller the residual, the closer to the best fit line you are. In terms, we kind of ignored this in lab last week, but standardized residual basically talks about how many standard deviations a point is away from the best fit line. Okay, so for case 1, it's basically saying case 1 is 0.685 standard deviations away from the best fit line. Okay, that's basically what standardized residuals stands for. But it's the same rule of thumb though as with the regular residual column. Okay, the bigger your standardized residual, the farther your data point is from the best fit line. Okay, and I think that'll be enough to at least get you through the exercise 21B homework. And if you have any questions, feel free to email me. Hope this helps.